Question 6. Okay. Find the equation of the lines drawn. All right. Let's start with A. So the way that we write down equations for lines that are vertical is we write them in a completely different way. We just write x is equal to the place it cuts through the x-axis, which is -5. That's the equation of the line. It's the only one that doesn't follow the y equals mx plus c, because if you were to try and figure out the gradient of a line like this, it's mathematically impossible. It's mathematically impossible because it rises forever and never moves forward. So it's run, so if you're looking at gradient, which is rise over run, it rises forever, so you could say it's infinite, and the run is nothing, which is 0, and you can't divide things by 0. You'll get a math error. So if you think about it, when you're dividing numbers, let's say 8 divided by 2, what you're doing is you're doing lots of subtractions of the same value over and over again until you get to 0. So 8 divided by 2 is 4, because you can subtract 2 4 times from 8. 7 divided by 7 is 1, because you can only subtract 7 from 7 once. But with this, you can subtract 0 forever and nothing will change. So this is an impossible gradient, which is why vertical lines are written completely different to every other line equation you've ever written. So this one is just writing the value where it cuts the x-axis, which is -5. For the line B, which is a horizontal line, so when we write the equation of the line, what we're looking for is the gradient and the y-intercept. The y-intercept in this line is 3. Okay, 0, 1, 2, 3, 4, 5, 3. So we have a value for that. The gradient, which is rise over run, this doesn't rise at all. So you would end up, if you were trying to calculate, you would end up with 0 over, I guess, an infinite amount of run. And that's just 0. So because if you think about it, gradient is how sloped a line is, and this has 0 slope. So you'll end up with a 0 for the gradient, which means 0 times x is 0, and so horizontal lines are just written as y equals the y-intercept, which is 3. For line C, this one here, it cuts through the y-intercept where it is 4. So we can write the general form, and not the general form, but the blank version, and the y-intercept is 4. Sorry, this one is y equals, oh, I already did that, okay. That's 4. What's the gradient? So there are a couple of ways that you can do this. You can use a formula. So on your sheet, you have a method to calculate a formula if you have 2 positions. Okay, so y2 minus y1 over x2 minus x1, sorry. And what you're doing by doing this is you're just trying to figure out how much rise happens for how much run happens. In other words, a rate of change. So you can do this using the formula, so let's do that. But first of all, you need coordinates to use this formula. So you can just look at it and just pick any 2 coordinates. I would pick the x and y intercepts because they have zeros in them, and that's easier to subtract. So on line C, the x-intercept here is the coordinate 4 with the y position of 0. And this one here, which is also 4, is an x position of 0 because it's right here, and a y position of 4. So now I have 2 coordinates. I can now use that to plug into the formula. So I have now 2 coordinates which are both intercepts, and the formula is y2 minus y1 over x2 minus x1. Let's call this position 2 and that 1. So y2 is 0 minus 4 over x2, the 4, minus 0. So 0 minus 4 is minus 4. 4 minus 0 is 4. That is minus 1. You can use the formula to do that. You could look at the gradient and just look at how much the line rises as it goes forward. So if you look here, from this position to then from x equals 0 to x equals 1, it's moved forward 1 and gone down 1. In other words, it's risen by -1. So by looking at it like that, you can then determine that for every 1 forward, it's gone down 1. So you could just write, whoops, yeah, it's gone forward 1, down 1. So you could just write, well, that's a rise of -1 with a run of 1, and then that equals -1 anyway. Or you can look at it over a longer distance, and you might do that because you want to accurately determine how much rise and how much run it's done by using a whole number. So you might go, well, if this line goes forward 1, 2, 3, 4 units, and in that distance it's gone down 1, 2, 3, 4. So that's a forward, so a run of 4 and a rise of -4, which will then give you -1 anyway. So to complete my line equation, I've got my y-intercept. The gradient is -1, so I can write -1x plus 4, and I can remove the 1 because minus x means minus 1x. Line D, okay, line D, let's look at the y-intercept. It cuts through where y is minus 6. So this information is minus 6. And if I use the technique from before, I can start at a position, and then if I go forward 1, the line moves up 2. Forward 1, up 2. So in terms of rise over run, rise over run. So so the run is how much it moves forward. So if I just looked at it in terms of 1 unit forward, I'll just put 1 there. And in that distance going forward 1, it's gone up 2. And so therefore the gradient is 2. You can see that it would work if you looked at a longer distance. If I started, say, here, and then I went forward 3, 1, 2, 3, so a run of 3. In a run of 3, it's risen 1, 2, 3, 4, 5, 6 units. So again, if I use rise over run, it's gone forward 3, and in that distance, it's gone up 6. So that still gives you a gradient of 2. Using the formula, you would have to pick 2 positions on that line. And so I would just, again, use the x and y intercepts. The y-intercept is minus 6. So that coordinate would be x is 0, and the y, that would be minus 6. And then it cuts through the x-axis here for the x-intercept. So this here is 1, 2, 3. So the x is 3 and the y would be 0 because it's in line with the y, the x-axis. So here are my 2 coordinates. Crap. Here are my 2 coordinates for the line D of 3, 0 and 0 minus 6. So if I use the formula of y2 minus y1 over x2 minus x1, and I've got 2 coordinates, the 2 coordinates being 0 minus 6 and 3 and 0, and I'll call this coordinate 2 and coordinate 1, 1, and so 0 minus 6, because in the formula it's got a negative, and I'm substituting a negative 6 over x2, which is 3, and x1 is 0. Okay, if I substitute in brackets to make sure that my negatives don't get confused with negative values and minus signs, and then 0 minus minus 6 is 6, because 2 negatives in a row like that means add, and 3 minus 0 is 3, and that gives me 2. So that's still consistent with what we were looking at before. I have a gradient now, I have a y-intercept, so now I can construct my line equation, and it's 2x minus 6.